This is the fourth section, the product rule of the differentiation chapter, and this is going to allow us to now expand the number of things that we can differentiate by looking at products. And these are going to be products of things which you can't simplify. So typically it might be something like y equals e to the x times by 5x minus 1 to the power 7, which is a product, and it's a product of two different things. So you'd have one way of differentiating that, one way of differentiating that. And what we do is we call one part of the product u, we call one part of the product v, and so we can say, right, this is basically something times something else, uv, and the product rule says this, that if you want to differentiate that, dy dx is equal to u times by v dash plus u dash times by v. Now that v dash is dv dx, or the v part differentiated, and this u dash is du dx. Yeah, so you could write it instead like they've written it above as u dv dx plus v du dx, or if you use function notation, you could say f dash of x, if we had y is a function of x times a different function of x, how would we write that? Say f of x times by no, we wouldn't write it like that. We might say f of x is equal to g of x times by h of x, like that. So two different functions, and that would be equal to g of x times by h dash of x plus h of x, or yeah, let's write g dash of x times by h of x. Yeah, so lots of different ways of writing the same thing. So really what you want to be able to do is identify which part is the u part, which part is the v part, and then both bits get differentiated, multiplied and added together. So let's have a look. So here we have a product because you can't simplify this any further. So I'm going to call this part here u. So u is going to be my x squared, and this part here I'm going to call my v. So v is going to be, let's write it as a power because we want it in that form so we can differentiate it. 3x minus 1 to the power half. Right, so now let's work out what u dash is, or du dx. That's going to be 2x. And v dash, or dv dx, that's going to be, using the chain rule, that's going to be a half. So you differentiate the outside, a half bracket minus a half. Inside of a bracket doesn't change, and then you multiply by the inside differentiated. So that will become 3 over 2 3x minus 1 to the minus a half. So now we can plug everything in using the same notation. F dash of x is going to be u, which is x squared, times by v dash So times by 3 over 2, 3x minus 1 to the minus a half. And we now want the v and the u dash. So 3x minus 1 to the half times by 2x. Now we can leave our answer like that. There's nothing in the question that suggests you need to simplify it or do anything further. That is absolutely fine as a final answer, unless the question said leave it in a particular form. Now I could actually here factorize this, because both terms have x in. Both terms actually have 3x minus 1 to the minus a half as a factor. So that means in the brackets I would put 3 over 2x to get the first chunk, and then plus 2x times by 3x minus 1, and that will give me the second chunk. Okay, and this is probably the most useful form, because this is helpful if you want to find, let's say, turning points. If you wanted to find when dy dx was 0 or f dash of x was 0 turning points, that's probably the most useful form to have it in. Something where you can say, right, okay, either this bit is 0 or this bit is 0. So here my u is going to be e to the x, so u equals, or e to the 4x. My v is going to be sine squared 3x. Now I want that in a form I can differentiate, so I'm going to write it like this: sine 3x all squared, like this. So my du dx, or u dash, would be 4e to the 4x, using that rule that we had, and the dv dx, or the v dash, is going to be, we differentiate the outside, so it becomes that. The inside doesn't change, and then we multiply by the inside differentiated. So there's lots of rules going on. Sine 3x differentiated becomes 3 cos 3x. Right, so now we can put these into the product rule. So u, so dy dx is equal to u, which is this, times by dv dx. So times by, and I've got 2 times 3, that becomes 6 sine 3x cos 3x. We could use double angle there if we wanted to change that to a double angle, plus v, which is this, du dx, so 4e to the 4x. Now they want it in a particular format. Now I can see that e to the 4x and sine 3x are common factors there and there, and I've got sine 3x squared. So let's take the e to the 4x out, that's a common factor, and we'll take the sine 3x out as a common factor. So to get those terms there, I would need to multiply by 6 cos 3x, and the second term would need to be multiplied by 4 sine 3x. That would work. So I found the values of A and B. A is 6 and B is 4. So that is now done. A6, B4. Right, exercise 9D on pages 242 to 243.